Hello everyone. So in this session, I'm going to talk about something we are already familiar, and those who knows it, it will be a refreshing session, and for those who don't, so it will be a new learning. Yeah. So in this session, we will talk about microservices, reactive systems, saga pattern, and how our design, and also we will see like how our design evolves as we progress with this session. Initially, we will start with basic design, but as we progress, we will identify problems and how to evolve it to fix those problems. Okay. So let's start. Okay. So I guess I already told you uh, two terms, reactive system and microservices. So now you might be wondering, like, what are those two? What is the difference between those two terms? I mean, aren't they nearly same? Well, yes, they are to some extent have the overlapping definition. I mean, if you see microservice, it came in 2011, and this term actually came up when during one of the workshop for the software architect, I believe, and in that workshop, this term came up, and that's what the year was 2011. That's first time this term came up, and if you see, I mean, I had pick up some definition from the internet, and the definition among them, two of them which I feel were easy to understand and has the uh, I mean, it explains very well. The first one among them is like it structures an application as a loosely coupled set of services. So yeah, it's a self-explanatory. It basically says like our application, it is just segregated into multiple services, and these services, they both collaborate and talk with each other to complete one process, or it basically does the one complete task as a whole, or yeah. And the second definition, if we see, it says like each service is owned by a team which has sole responsibility for making changes. So basically, if you see, that's how microservices are basically being I mean, designed. Like it is basically created based on the business capability. Each services solves some business. I mean, it solves some business problem, and it basically a solution to those problem. And yeah, since it represents one business capability, so it is also owned by a single team who is responsible for making those changes. So yes, I mean, now we understood this definition. And also, if you see, microservices are also referred uh, like as independent deployable also somewhere. I mean, the other definition, if you see, it is also referred in terms of loose coupling, fault tolerant, and flexible. And if you see, the definition, that is something what even reactive system also has, and those are all overlapping with its definition also. So reactive system came in year 2014. So yeah, it came 3 years after microservice, and it has this characteristics like it should be responsive, it should be elastic, it should be resilient, and it should be message driven. So it's clear like if it is not responsive, so then there is no I mean, there's no meaning to talk about other three characteristics like elastic. I mean, yeah. So yeah, that's something a responsive system should have. It should be responsive. And for a reactive system, if you say it's like saying reactive coding in a non-distributed way. So yeah. So now what we will be doing in this session is like we'll be taking I mean, the idea from microservice and from the reactive system, and we will evolve our application, our basic application, and we will see like how can we make it more reactive, and also make it better. Yeah, this impatient customer, and he don't like to wait for a long time. He want uh, his order to be delivered within a 1 day or a 2 day. So yeah. So this impatient customer visited to one of the local digital store where he liked some television, and he just came there and for purchasing a new one for his house. And now he's ready to place his order, like let's say he want to buy a new machine. And so he just goes to the desk, and he says like, I need this brand washing machine. And also I need to, let's say if he wishes to place exchange service, I mean with his existing washing machine. So he will say like, yeah, I need to have an exchange also for my existing machine. So he just goes on the desk and says like, uh, just place my order. And the guy who is on the desk, he just goes and checks whether that service is in the warehouse or not. And whether it's available to be delivered or not. And also the washing machine which he has, whether is it eligible for the exchange or not. So yeah, he just makes the call to do those separate services, and he checks for those. Now next thing is like, the service receives the reply from warehouse service. Like he says, okay, I have this item, I can confirm it. So he says it just reply back the detail uh, from which warehouse that machine can be sent. And the service also just check like exchange service, whether that item can be picked and what rate can be picked if it is eligible for the exchange. So yeah, he gets those details also. And then he just simply goes and places his order. I mean, yeah, that's where the desk service assigns someone to deliver his order to the customer address, and also someone to pick up. So he can be the same guy who is delivering, or he could be be the different guy. So most of the time you will see it's a different guy who goes and pick up his delivery. And now, if you see, let's see the how the communication between desk service and warehouse service happens. So now we actually saw it is like a synchronous communication. That is the one way we can have. So in this approach, our warehouse service will expose one API which ends with slash warehouse, and it has the controller basically. So it expect like in the payload for the request, it should have this order for which it can prepare it. And I mean it can just ready to I mean it will deliver to the user address. And once the desk service gets I mean, that's what from this part of the code you can just understand in the warehouse service. And second part of the code, if you see, it's a request handling. So it's just like um, if it gets the request for the order, it just simply just goes and use the REST template to make one HTTP call to my warehouse service, and it says, okay, use this URL and this is my order, and go and create this order in the warehouse service. Yeah. So I mean, if you see here, desk service basically calls and wait for the warehouse service to finish. So this might work, but it is a blocking code. And so it means like my sorry, so yeah, it means like this current thread will not be available to be used by other for request handling. So yeah, it's not a good thing. And so it is fine for low traffic, but if you see for high demand, this architecture will be bottleneck. Yeah. Okay. So now, if you see, this is what my architecture will looks like. If I'm going with uh, the REST template approach, that's I mean, it can be easily achieved while using a Spring component. But if you see, this architecture has lot of blocking code. I mean. here you can see between the front end and the service, that's one. That's something reasonable. But if you see there is a blocking code between warehouse and the service, and then exchange service and the service, yeah, and again between warehouse service and DB, again the service and DB. So yeah, there is a many, I mean, lot of blocking code. So we can understand it's not a responsive code. Okay, so now we understand it's not a responsive code. So we can say it's blocking, and if it is blocking, then there is no need to uh, I mean, check for the other things like elastic, resilient, and message driven. So yeah, let's see what can we do to make it non-blocking. So one way is like we can go with asynchronous communication. Yeah, so basic idea behind asynchronous communication is like we are not going to wait anymore. So here we just make a request, and it returns immediately. I mean, the warehouse service returns immediately. So here, once warehouse service has the data, um, it will just inform my data service, and later on my data service starts consuming the data. Yeah, so now we understand, like here my day service, after making a call like here to my warehouse service, it will not wait. It will just returns the, I mean, my current thread. So yeah, I mean, now that can be used by other request handling. So that's the one thing we achieved using asynchronous communication. And so my warehouse service, it receives the request, it goes and prepares, and once it is ready, it just start returning the data, and my the service will try to get those data and convert to my order type. Yeah. So yeah, I mean, this I mean, this approach creates the possibility for a high demand as more threads are now not now, I mean, it will sooner be available to use. All right, so this is what my architecture looks like. And in this architecture, if you see, we now have also gone a step one step ahead, and we use the reactive framework to make our DB call also asynchronous. So yeah, if you're using a MongoDB, then there is a reactive framework from Mongo also. Yeah. Okay, so this looks good. I mean, yeah, we see it is now responsive. But yes, as you see, as my application keeps evolving and new services are created, we now have to manage those many APIs and interfaces. So yeah, there is another hassle. Now, with this architecture, so I mean, we have got the characteristics like responsive, elastic, using Docker and Kubernetes, we can achieve that. Um, about resilient, I mean, it is not, because if one service fails while processing my request, it will lose that request to. So yeah, if any other service comes up, it will not get a request again. So yeah, that is a problem. So yeah, it's not resilient. And the next is message driven. So if we talk about distributed system, so it's not actually using messaging. So even though the code is reactive, but system is, I mean, a system level view, it's not really distributed. Even though the code is not blocking, but for it to be distributed, I need to use some messaging that is something consumed by my new API. Because having a messaging has its own advantages, like I can have a boundary between systems. I mean, I can establish using loose coupling, then isolation. Uh, After, yeah, so that's a positive thing. And also, like, I can also enable some advanced capabilities like load management, elasticity, flow control. So yeah, that's something messaging enable is something. It solves a lot of different problems. So yeah. Okay. Now, if you see, as more services keeps on growing, so there is always a question like, how should I be implementing my business logic around them, and where should it be? So yeah, it's always a, a kind of question we always ask whenever we are writing any change, and if you think like a common way to do this is like using microservices, then we need to use a saga pattern, because it just says like, I mean, yeah, I mean, using this pattern, it says uh, like all the business logic should be taken care by one service, which is basically the one who is implementing the saga, and also it is responsible for it. So yes, so that's the one way. Okay. So now the question is like, what is saga? I mean, uh, if you see in the correct in the current architecture, so in this current architecture, there is no way to ensure like about my data consistency for the process. And if something goes wrong, how can a dev service know like what sequence of action it need to perform to make the application state consistent after failure? And as we know, like as application evolves, it will become a lot more complex. So yes, so now we understand like having saga pattern with reactive is not going to be easy. I mean, it's basically not just, I mean, it's very difficult. It's very difficult. So yeah, so let's see, understand like what saga pattern is. So as per the definition, I mean, so it is basically used to have data consistency. It's like it just helps with data consistency, a sequence of local transaction. And here each local transaction updates the database. So once that service finishes, it just publish an event, so that it can trigger or notify other service in the saga. A saga is nothing but the process actually. And let's say if my local transaction fails due to any reason, and it then I mean, the saga then executes a set of steps so that it just revert whatever the changes happen for that application, to revert it back to previous state, or we can say a consistent state. Yeah. All right, so now we understand like saga pattern. Basically, it solves the problem like data consistency, which is something not very easy to achieve if we just simply go with the reactive uh, system. I mean, just a coding. So yeah, and like as we understand from the definition, I need to. I mean, even in the current slide, if you see 2PC something, it's basically used in the distributed transaction. That's the approach, but that is something very difficult and to have. So what saga, I mean, the approach saga says, it's like each service will do its local transaction, and it will just creates the event so that other service can listen. It will do its own transaction, and once it's done, it will trigger another message or the event that is read by some other service. Okay, so now we understand we need to think about messaging in a distributed system for us to use Saga here. And the common way is like we can have a message broker, which nothing but enable us to have a loose coupling. Yeah, so now we understand like why we need messaging, and the reason is like we have to have a saga here, and because that will something handle my business logic. All right. So Now it's a message driven. If we adopt message driven, so I need to have a message broker. So now if you see, there is desk service, there is warehouse service, and um, here my desk service has this um, code which simply just sends one event like shipping ordered with this order ID. So it just says like, I need to have the shipping to be done for this customer, and it just publish this event here in the message broker, and message broker later on consume this topic, and it just does something like here in this in the example code. It listens to my topic shipping order, and it gets the order ID because that's what it expects. It does something, and it just then sends the confirmation with the order ID, like it is ready, or it is shipped, something like that, or it is ready to be shipped. And that is something it just publish that to another topic that's in the consumer desk service. And here if you see, my desk service doesn't need to know about warehouse service now, because it cares about is message payload, like how it looks like in the order. So yes, we have created a boundary now, and also with the help of messaging. So there is like a isolation basically, like because my desk service doesn't know what are the other available or services are there in the ecosystem or in the platform. All right, so yeah, this looks good. And after exchanging those uh, interfaces with the with I mean the rest interfaces with the messaging, like PubSub. So now this is what my architecture looks like. It, it has now message broker here, and my Panda service receives any order through front end. So there is this REST endpoint still there, and let's say the order comes in, it will just go and create one event in the message broker on the specific um topic. That topic will be read by my warehouse service, and it will prepare it and have some local commit in its own place, and then it will send the confirmation again back on the broker. That is something again my desk service reads, and just hold, or maybe it waits for SC service to be finished, and then gives back that data to the customer. So yeah, that's something looks way better. And yeah, I mean it's good. So now here if you see, my desk now, my business logic is basically in my desk service, because my desk service now has those logic, like what things it needs to do for it to be treated as complete. So yeah, awesome. I mean, we achieved all four here. Like now, if you see, this architecture is responsive. So now, if you see, nowhere in this code we have a blocking code, and so now it's a responsive. Yeah, we are elastic here. So I mean, if you see, I can use Docker and Kubernetes to make it scale each services. So yeah, it's elastic, and it's also resilient. Let's say if one of the system fails, we can we will be able to recover it and continue the job. So because it's a message broker, message will be still be there. It can be picked up by the other service. So yeah, and even let's say if one of the services still it has to pick up the message, and it's crash in between, so that message will again be available to be consumed after some time. So yeah, that's the benefit we are getting with the help of message broker. So basically, we are having a better resiliency here, and again, we are using message driven now. So it looks good. Yeah. But there is something we are missing. I mean, let's see. I mean, no, as we know, like it will not be in reality. There won't be only two or three services that will be handling my business, right? There will be a lot more, and to name a few, for my own small application, there will always be a service like EMI service. So let's say my user want to purchase washing machine on the EMI. He don't want to pay full amount upfront. So yeah, that's something, one thing. uh, so there might be another service like BNPL service where I mean, that store itself provides this service from their side, where they have some quota where they can just give some credit amount that can be used by the user. Another is like offer service if there is any ongoing offer happening. So yes, this is also a essential thing. Now there can be a payment service like how user wants to make the payment. Is it like a EMI, or is it like a full cash upfront online payment, or a credit card, anything? So yeah, there might be a login service so that we can have the details for each user and have the personalized content. Now there will be also a thing like header service, so that if a user have any query, so he can ask to the help desk. And there is a audit service, so it's like an internal thing where business has to have the auditing. So for the compliance reason, there might be another thing called compliance service. So you will see like a lot of more services are there, yeah. And it will keep on growing as my business grows. So so now if you see, like there will be a lot of messages going around in the system, and it is really complex situation now. I mean, to debug those issues, I mean, to debug issue, if customer didn't receive his shipment on time. So yeah, let's say, I mean, this is a pretty I mean, I will not say it's uncommon. I mean, there is always something, this scenario
One or
you,
two
you might
percentage
face
face.
cases. So, and let's say if he didn't got, he might go to Twitter and he might tweet about the company, or bad mouth about the company. And it can do bunch of other stuffs like ruckus in the office and many other things. So, now if this customer comes in and he says like, where is my order yet, where is it, why I haven't got, it should be, it should have been delivered to my address in 2 days, why is it not yet available? And if it comes to the developer, like who will be going to pick up his complaint, he might he don't know. I mean, uh, I mean, let's say I don't know. System may seems fine. I mean, there is no issue reported. Like the developer might say, he may say like something might have gone wrong with the payload, but I don't know like how to debug your issue now, because that is something happened a long back, and I don't know how can I read it, because that is not something I have tracked or logged. So yeah, it's a problem because it's now hard to understand uh, the logic and the flow of the system, because I have no ability, uh, sorry, visibility, which message is being sent and all in the system for his order. So yeah, that is one problem with I mean this architecture has. So so yeah, there is also a question like, what can I do to the current architecture so that it enables quick problem detection? Observability is just uh, it is just a complement, but it is not a primary approach to detect problem quickly immediately. It is good to have observability, but that is not the primary approach to detect problem. So yeah, and also we will just understand like what goes on in the system. Okay, so to have that capability, like quick and immediate, to detect problem, I need to have a state in a reactor system. I mean, a state which knows what happens to the order. Because if you see in this architecture, there is no state. I mean, there is no way I can know what happened to his application. Okay. I mean, we can change the current architecture by adding state to our reactive system. So there are multiple ways to achieve it. And like so we know, I mean, we don't know that saga pattern is the answer. So there is two ways to have it. One is like choreography based saga, another is like orchestrator based saga. And in this approach, we will going to talk about uh, orchestrator based saga. Okay, so now we know, so now let's see like how can we have the orchestrated way saga. So yeah, let's see. Okay, so now if you see orchestrated way means there will be someone who will be orchestrating whole process. So so now let's see what workflow engine is and what it does. So in this slide, you will see a basic flow which calls three service for completion. Here, workflow knows like what things it need to do, and what are the dependency for the next step. So here, workflow define a saga and can be a orchestrator in a microservice in the architecture. Instead of going from event driven, we can go with orchestrating. Uh, yeah. So we know the saga basically a process. Uh, I mean, when we start the saga or a process, and once we arrive at service A, the service A does its action and then goes to service B and later service C. So now you can see like there are multiple workflow can be achieved using this basic idea. And yeah, so okay, it looks okay. So now it also means like my application, I mean, service B will not be called unless and until service A completes its action. And here, service B, let's say if goes back to service B, so service B may be talking using a synchronous way, maybe service. So in that case, workflow engine has to wait for service B. Uh, like it may listen to some events, a completion event. So that's one thing. And then maybe service C is a synchronous communication where it has to wait for some time for it to complete. So yeah. Okay. Yeah. So now we now understand this is what my architecture will looks like. So we already know like my workflow engine is something. Uh, it can be. I mean, it can be an orchestrator in a microservice. So it can be something. I mean, this can be inside my dev service now. So it basically maintains state. So whenever any API request from the front end comes to my dev service, it will check what has been happened for that request or the order ID for that customer, and it will see what was the last thing it has done, and it will, based on the state, it may wait, or it may do the next thing. So yeah. And there is a message broker. So basically, because now everything is reactive, so every communication is happening through message only. Okay, so now we understood, we have a workflow engine. So it is not nothing but the orchestrator. So now if I just go back and see, so my business logic is actually inside my dev service. So it knows for a order to be shipped or to be set as delivered, it need to reserve this order in the warehouse, and then it need to ship to the customer address. It also need to accept payment from the customer. Then it has to send invoice to the customer, and also send some communication to the customer. So yeah, so like there are many more things, and those things will comes in my desk service. It's a orchestrator, so it knows like what it has to do to make it finished, completed. Yeah, I mean to be assumed as completed. And this is what my code will look like inside my desk service. So it's a very high level. I will say what is happening in my desk service. So here customer enters my shop, he just picks up order, uh, and then he just goes to my desk service, and he says, hey, just I need to buy this order, please help me uh, uh, ordering. So yeah, now my desk service will go and uh, first it will check the product, it will then place my order. So yeah, so now if you see place order here, it's basically a decision branch, so where it sees like whether the order is with exchange or without exchange. So let's say if it is with exchange, so it will execute flow one, where flow one is like it will just go and uh, e- together, I mean consequently execute uh, for exchange as well as for shipping. And then it will wait, I mean yeah, it will wait for the for it to be completed, because my next step, like you see, it's a payment step. So for a guide, I mean for the user, for us to ask him a payment, I need to get the confirmation like it is available and can be shipped. So yeah, that's why I'm depending on the previous step for it to be finished. And then I will ask the user to make a payment, and I will check for his payments status. And like once the status is completed, I might create the invoice and send the communication. So yeah, that's how you see my business logic is inside their service. So it's a very I mean this is a very uh, a clean way, I will say, because my business logic is now not distributed in different services. It is in one particular service, and it knows like what are the things or the services it needs to communicate to make it completed. And also my this service, it knows like where my application I mean status of my application, what are the things being done in that application, and where it is stuck, or where it has been progressed. Yeah. So now we saw like those are the code, but we didn't saw like how workflow engine is basically fitting. So yeah, so now this is just the another way to represent that same code. I mean, like here I saw we saw like a very high level, like it will do this thing next. But what happened is like those thing is nothing but a step, uh, a basic step. Like order product will be one step that it needs to be completed. Then placed order decision, it will be another step where it will have a flow one and flow two. So yeah, it's a, like flow two will be like without shipping. So yeah, it will just I mean sorry, without exchange. So it will just go and ship the order without any exchange. And the flow one is like there is some exchange also that my customer is expecting. So yeah, these two call will be happening, I mean these two flow will be happening, which will create one event, and the intended service will consume it, and if it do something and just give back the confirmation. And once that confirmation is received, my next step is in either the flow is like payment and to X. So now if you see this red colored, it means it's a customer step where customer input is required. And the green color, if you see, it's like a system step where this execution will happen automatically. So there is no user involvement. So now it's also like we can just go on and improve this thing more and more. And yes, so now my application already knows like where my request has been. I'm in this journey. I mean, where it is in this journey, and what are the things being done, and where and for what step it is waiting for it before moving ahead. Yeah, and these are the things like make payment, create invoice, and communication, and completed. Like your order is delivered. You can say anything in this step. So yeah, this is what inside my desk service. So now if you see from the front end will send one order, and that's something will hit my desk service at this end point, like start journey, which will like whatever payload you're sending from the front end, it will be something taken as a place or this product, I mean order product, where it will get my orders. It may go and validate my order and then save in the DB. It will then has the other detail also, like whether it is exchange or not. And based on it, it will trigger my flow here. Let's say it is with exchange. So with exchange will trigger two flow, two call. One is like shipping order, place shipping order, and other is like place exchange order. So yeah, shipping order will create one event that will be read by my warehouse service, and place exchange order event will be read by my exchange order service. So yeah, and both of these services will do their own action and create another event that will be read by my own service, and it will then move to this step. Yeah, and it will then say like user need to have to make the payment. So yeah, this is where my service will go and stop. It will start here, it will do this thing in sequence, and will go and wait for the user. Now what happened is like uh, now once here user hit place order, it will return immediately like okay, your order is being placed. uh, we are waiting for the confirmation, like for your order to be confirmed. And next thing is like from the UI, it will then navigate the user to make payment, where that is where this step you see. And user goes and does the he follows those multiple screens to complete the payment. And once he does, he will get the confirmation from the service like your payment is done. And the next step is like in progress, something like that. Next step, it is waiting for is like completed or in progress, something like that. So yeah, yeah, it just those payment is done, it will pay the invoice, it will send the communication. It is because once he does the payment, he it completes, it does the steps in sequence, and it says like okay, your order has been placed and completed from your side. So it just sends completed as the step ID. So it knows like this is the next step my application is seeing. So UI can appropriately show the right screen, and you will see like there's also still like send communication where it goes and notify user. It could be through email or SMS. So yeah. Okay. So we saw like a very high level. I know it is uh, quite interesting. It's just like we are using saga pattern. So yeah, my state is being managed, and this workflow engine make sure like my invoice service will not be called before payment is done, and my payment service will not be called before order is being confirmed. Yeah, so yeah, it's very I mean, interesting. I mean, yeah, my system is reactive, and it also using it's also waiting for previous order to finish. And since this details is already been maintained uh, by maybe by a state manager, let's say. So yeah, using that I can understand and quickly debug and come to know like how where is it stopped or stuck, so I don't have to go and see long logs in the application to just identify my application. So yeah, and yeah, I mean, using my logs, I can also go and see the exact reason. But yeah, that's the quick way we can have we can find the issue in our system. Okay, so we already saw like there are some complex flow like place order decision flow, and let's see like what it basically does. So now if you see, place order is simply uh, a step which is a decision step, and it is inside the service. So it expect two kind of step, like with exchange and without exchange. So yeah, I mean, it will expect like order detail has to be sent to it for it to make a decision, and it checks like if order is having the uh, request for exchange, then it will call with exchange flow, where it goes and call this to um, separate steps simultaneously. And then there is a place shipping order. Now let's see this step, like what happened inside this step once a decision is being triggered. In other flow, we do the place shipping order. So if you see, this has the dependency on the producer, where once it gets the detail for the order from the user, it just goes and produce the event on the shipping order topic. So that order goes to my message broker, and that is something being read by my warehouse service on this topic, and it it will get the order ID. Here we see identifier, but it just translate back to the order ID. Yeah, and it is something, and they send back the confirmation like, okay, your order is being confirmed. So yeah, I mean, yes, this is what, if we just go back and see, it waits for the confirmation, and once that confirmation is being received, this step then will mark itself as completed. Otherwise it will be in progress and this will not be called. So yeah, this is very interesting. Okay, so I know we talk a lot about the theoretical part, like how this flow will happen, but are there any tool or framework already available which avoid me from implementing those complex things? Yes, we are in luck. There are many tools, and one is like Netflix conductor workflow. So it also has its workflow engine, where you can go and create your own process or saga. Sorry, you can have your own decision branch decision. Like here, it has already one decision. It's just a diagram I picked from their documentation. You can have this complex flow using Netflix connector. It is achievable. So yeah, you don't have to implement that framework. Okay, and we also have something similar in AWS, step function basically. So using step function, you can also have this UI. Using this, you can drag and drop and create your own saga here. Yeah. All right. It looks like we already have those tool available. So if you don't have any, I mean, if you have no reason to use, not to use this, then go ahead. I mean, go and use this framework. It's quite good. There might be some edge cases, like if you see in the conductor, there is no way to resume or the journey or something like that. So yeah, if that is something or there might be any, I'm not sure right now whether it's implemented or not. But yeah, if you have any other cases which is not been covered, then you may have to go and implement your own framework, and using this idea of workflow engine, you can achieve it. Yeah. Okay. We understood, but that was pretty interesting. Do we have any other example? Okay, yeah, I do have. Let's see another example. It might be a bit complex, but yeah. So right now, I saw like the previous example we saw. It was like only handling one use case. But let's say I have a use case where there might be a different kind of user, and I need to have a same. I need to have an orchestrator which understand this different user, and based on some identity, I need to do a different journey. So yeah, I need to expose same endpoint, but I need to have a different flow for different user. So yeah, it is a bit complex. If you see, it's like um, two variations or two types of user. Okay, so now let's say I I am designing one forex application where user can go and buy US currency from using their own country currency. So let's say this application already has two kind of user. One is like ETB. So now he can be something existing to the application, and the next is like NTB, something like new to the application. So we understand like ETB is just a code we gave for the existing users to for a way to identify him, so that he can just go and do this kind of journey. And for NTB, like you can use this as a code to as identifier to for using the new journey or the different journey. So yeah, till this point, I mean till orchestrator, it will be a REST call. Using the REST call, my orchestrator will know like this is what the user type is and what flow it has to pick. That's something my orchestrator will decide. So my orchestrator goes and using the journey code, it will pick up the process, and it just executes it here to run the step and give back the next step or the reply or the response back as the rest HTTP response to the user. Same thing is true for the NTV user. All right. So let's see how my uh, orchestrator will look like. So I mean, uh, it will look like something similar. Like there will be one endpoint uh, which will have something. Let's say since my application is forex, where you can go and buy US currency. Let's say, so I will say like slash forex v1 external start journey. So there might be many things happening between this step and this step. Like this gap, I mark as one. So one like between this step, there might be many things you might have want to do, like a logic, like you just go and check whether the um, customer whatever, or let's say application he has placed for the currency, is it something already been in progress, or was it already created? If not, then you may have to go and create a new one. And let's say if he has created, then you may want to do something before starting his journey. So yeah, those kind of complex logic you can add in your orchestrator, where when it gets the HTTP hit, I mean the request, it will just go and do those complex thing. So that is something you can add in your core library, which is nothing but implementation for your orchestrator. And then once the uh, whatever logic is completed, I mean the pre-processing, or what to say, it's completed, then to go and call my actual step. Like this is what you can say, a process which has multiple steps, a step, yeah, there might be different step. So I'm in this slide, I'm not going to talk about what are the things it should do, but I just want to know that like the different approach you can use to design your workflow engine. So one way is like you can have your orchestrator in a code library where it can be shared with other application. So you can create some kind of template like define process where you go and create your a chain of steps which it has to do. For example, like this one here you see. So I mean till this I mean after first action, there might be first step and then many more things. So this can be something it can be used as an abstract step in the code library, and the one who is going to create one new saga, a new process, he will just go and implement that step. And yeah, so this is one way you can uh, abstract those things, yes, in the code library, and let the application or the one who want to create different saga go on and implement it. So it can have multiple steps like parallel step, go and execute things in parallel, make some decisions, and then use some kind of termination and do things differently. So yeah, so now if you see, this is something what looks very similar to workflow engine, like what we initially talked about, and it's basically the same thing. And also we see like tools like Conductor and Netflix, they are also doing the same thing. There is nothing different. And if you see state, I mean here if you see my state is being managed by the orchestrator in a coordinated saga pattern. And in reality, if you see, the saga is something that, I mean, the process, it creates a new request that is being sent from the, I mean, creates new saga or the process whenever a new request hits by the front end. And here, orchestrator is basically responsible for containing the base logic, and and also knows the state of each request. So yeah. So and like other services don't know whether any state is being managed or not. So yeah, that's a plus thing. And if you log in again, Saga just goes and checks the state, and based on that, I decide what to show you next. And let's say if everything goes wrong, then we can go and check the state logs and realize where it's stuck. And based on that, we may go and debug the issue to understand. So yeah, basically this approach, it just speed up the way we can easily debug the issue and quickly identify the problem. Sometimes you may see observability, like having Kivana or the other thing, it might not be sufficient. There might have something might happen in those side, and you may lose everything. And yeah, having this state, it's really wonderful. Yeah, thank you. I mean, that's all in the session. I know it was a long session, but we really enjoyed, and it's a great one. Thank you.